Hello friends, let's work out some problem related to invertible functions. So I hope all will be knowing what do you mean by invertible functions. Invertible function is nothing but g of f is equal to ix and f of g is equal to iy. Then you call that function to be invertible. Let's see how it is. Let f be a function where n is related to y, be a function defined as f of x is equal to x plus the 4x plus 3y, where y, which is given as y is an element of n, y is equal to 4x plus 3. So y is equal to 4x plus 3. Let's define g as a function related from y to n. So therefore we can derive what is x here. X is equal to uh, y minus 3 by 4. This is x. So therefore what is g of y? It is nothing but y minus 3 by 4. Now our aim is to find out what is g of f, and that should be equal to ix. In this case x is not there, so first function is n. So since x belongs to n, I can just write in, and f of g should be equal to iy. So what is g of f of x, which is nothing but g of f of x. So g of f of x is 4x plus 3, and you need to substitute uh, wherever g of y, that is g of y is y minus 3. So wherever y is there, just substitute 4x plus 3. So that will give you 4x plus 3 minus 3 by 4, which is nothing but x. X nothing but belongs to n, so I can just write in. So I got g of f is equal to in, that is equal to x. Next I'll find out what is f of g of y, which is nothing but f of g of y. We have defined what is g of y, it is nothing but y minus 4 by 3. So now wherever in f of y minus 4 by 3 means wherever y is there, like x is there, substitute the function, like where that one. So it will be 4 into y minus 3 by y minus 4 by 3 plus 3. So it will become, sorry, the equation is y minus 3 by 4. So you need to write it as y minus 3 by 4. So here also please do the changes, y minus 3 by 4. So the answer will become 4y minus 12 plus 12 by 4, which is equal to y. I can write it as iy. Since f of g of f is equal to in and f of g is equal to iy, I can say f is invertible and g is the inverse. I hope you are clear with this. This is how you do invertible type of functions. Next we'll move on to an important theorem which tells you if x, there are three functions given, that is f, g and h. That means x is related to y is one function f, y to z is a function g, and z to s is function s. These are the three functions. If such a case arises, then they tell, according to the theorem, h of g of f is equal to h of g of f. Let's prove this theorem with the help of, let's prove this theorem with the help of an example. Say in this case they have given three functions, that is n to n, that is f, and again n to n, that is function g, and then n to r, h, that is function h, and they have defined what is f of x, g of y, and h of z. You need to show that h of g of f is equal to h of g of f. So let's take LHS. So h of g of f. First let's find out the bracket. What is h g of f of x? I think I know, like it can be written as g of f of x. So f of x is nothing but, according to the question, it is 2x. So g of 2x means wherever, like g of y, wherever y is there, replace it by 2x. So that will become g of 2x will become 3 into 2x plus 4. That will become 6 plus 4. 6x plus 4. Then h of g of f is nothing but h of g of f, which is nothing but h of g of f. You have got x plus 4, which is nothing but h of g. That means h of z is sin z. So instead of z, you can just write x6x plus 4. So this is h of g of f. Now let's find out the second one, taking RHS. So RHS is h of g of f. So what is h of g? First find out. H of g of y. Since g is a function of y, you will get h of g of y, where g of y is nothing but 3y plus 4. So h of g of y is nothing but sine, wherever wherever z is there, replace it with 3y plus 4. So it will become 3y plus 4. Now find out the next half, that is h of g of f of x. That is nothing but h of g of f of x. You know what is f of x? That is 2x. So now h of g of 2x. That means substitute instead of y 2x. That will give you sine of 3 into 2x plus 4 will give me sine 6x plus 4. So you can say that 1 and 2 are equal, hence that is what they have stated in the theorem. I hope you have understood this. Next we shall move on to the second theorem. What does it say? Let f be a function related to x, y, and g be a function y to z. They both are invertible function. You know what do you mean by invertible function? Then g of f is also invertible with g of f inverse. That is, they tell g of f inverse is equal to f inverse of g inverse. They will be equal. That is what they stated in the theorem. Let's take an example so that we can prove the theorem with the help of an example. So function f is given. Let's just mark it up. 1, 2, 3. F of 1 is a, f of 2 is b, and f of 3 is c. So this is function f. Since function f is, they have asked you to find out, so that f, g and g of f are invertible. Since f is 1 to 1 and onto function, you can see f is 1 to 1 and onto function, therefore f is invertible. Similarly, you can just mark up function g. Function g is from a to a b c to a apple, ball and bat. So you can just write apple, ball and cat. A is related to apple, f of a is apple, g of b is, g of a is apple, g of b is ball, and g of c is cat. This is function g. So since g is also 1 to 1 and on to function, g is also invertible. Now let's find out g of f. You know what is g of f? G of f is nothing but the second function is written first, followed by first function. So it is nothing but f of 1 is a is f of a is g of a is apple. So directly you can write 1 is related to apple. So I will directly write the arrow diagram. It is nothing but apple, ball, cat. So this is g of f. So since this is also 1 to 1 function and onto, you can write g of f is also invertible. What do you need to find? Find out f inverse, g inverse and g of f. So what is F inverse? You can write it directly, just interchange it. A, B, C, 1, 2, 3. This is F inverse. And G inverse will be apple, ball, cat is related to A, B and C. So this is G inverse. Now what is G of F inverse? G of F inverse is directly, you can just write it. That is apple, ball, cat. Just reverse of G of F is related to 1, 2, 3. This is, you can just name it as G of F inverse, since they have asked you to show that G of F inverse is equal to F inverse of G inverse. So this I can take it as 1. What is F inverse of G inverse? That means always, second function is written first in the symbolical way. So second function, I'll move to the next. So first function, if you want to find, G will be the first function. So it is nothing but apple, ball, cat. So it is A, B and C. So I'll write this. This is G inverse, and F inverse nothing but A, B, C, which is related to 1, 2, 3. So this is F inverse. If you want to write the composition, you can just write directly over here. I'll just write it here. So F inverse composition G inverse is nothing but apple, ball, cat is directly, see this last, first and third, that will be 1, 2 and 3. If you take the second, when you compare 1 and 2, you can say that G of F inverse is equal to F inverse of G inverse. I hope you are clear.